The Harvard MIT math tournament is known as one of the most difficult math competitions in the world, but it wasn't always this way. This is a question 8, I believe, out of 10 from just a few years ago, and it's actually a very, very simple question. So before I even get started on answering it, I encourage you to pause the video, try it yourself, and see if you can solve it mentally within a minute or two. Okay, so hopefully you pause the video and give it a shot yourself. If you couldn't do it mentally, hopefully you still tried it and were able to at least make some progress. Now let's take a look at it. What is it asking us for? It's asking us to find this sum, and it's a pretty long sum, right? We're going from 1 and 2, 2, 3, 3, 4, all the way to 14 and 15. So obviously the right approach is not to list out each term, simplify it, and then add it up because that's going to take forever, right? It'll probably take longer than the entire exam. And so we need to find something else. There are a lot of patterns over here that you might notice. One of them is that 3 is 1 plus 2, 5 is 2 plus 3, 7 is 3 plus 4, and so on, right? 29 is 14 plus 50. That's a good pattern to recognize. And it's definitely useful, but it's not immediately as useful as we'd like it to be. But we can still write that, right? So we have 1 plus 2 over 1 squared times 2 squared plus 2 plus 3 over 2 squared times 3 squared. Now, how can we continue from here though? Because yeah, sure, we've made some progress here, but this doesn't really bring us closer, does it? Well, take a look at this. 1 and 2 are adjacent numbers, 2 and 3 are, well, consecutive numbers, same thing. So the difference between them is always going to be 1, right? So what if I just do this then, and it's a slightly weird thing that oh, one sec, yeah. It's a slightly weird little platform that I'm using, so I'm going to be a little cramped for space, so I'm just going to continue it like this, and then say, well, I'm going to write this as 1 times 2 times 2 minus 1, which is not changing anything, because 2 minus 1 is just 1. So all I'm doing is multiplying it by 1, which is completely fine, plus 2 plus 3 times 3 minus 2, right? And maybe you can see the reason that I'm doing this. Maybe you can't, but that's fine because you'll see it soon enough. Okay, so sure, this helps us a little bit maybe, but in fact, it might look even more complicated to you. So let's see, what does this look like to you? Well, this is a plus b times a minus b, or I should say a plus b times b minus a, but that's the same thing, right? And so this can be written as 2 squared minus 1 squared over 1 squared times 2 squared plus 3 squared minus 2 squared. That's another pattern that you could have noticed right off the bat. 2 squared minus 1 squared is 3. 3 squared minus 2 squared is 5. This is just the idea of difference of squares, right? And I'm kind of taking a lot of time with this here just so that you can maybe, in the pressure of the test, maybe you don't see that right away. But there are other ways to get to it as well. And the entire motivation for me doing this was just because I've done practice questions where I've seen that you get these sorts of simplifications and you can do it. But you should definitely be looking for those sorts of simplifications here, something that will make your job a little easier. And usually when it's long sums or products like this, that idea is telescoping, right? So I'm gonna just finish working through the problem here, and we can kind of continue it all the way out here to 15 squared minus 14 squared over 14 squared times 15 squared, right? And yeah, so the main idea here is telescoping. If you aren't super familiar with it, I'll probably have a video on my YouTube channel that you can see, or you can find another one if you like. But essentially, telescoping is when you have a few terms that remain, but the vast majority of them cancel out. So you might have that can come up in summations where you have like plus x, plus y minus y, and so on. Might also come up in products where you have numerators and denominators canceling out. But it's a super useful technique, and it's usually one of the most common things that comes up when you've got a question like this, because there's no way you're going to actually evaluate this raw, right, like manually. So okay, now before we finish off the question, if you've stuck with me this far, I really hope that you can please consider subscribing to the channel, right? It'll really help me out, and you can stay in tune, and I'll make a lot more of these sorts of videos that you can watch and enjoy as well, hopefully. So yeah, just make sure to subscribe, and now let's finish this off. So well, notice one of the key, properties of any fraction is that you can break it up. So 2 squared over 1 squared times 2 squared minus 1 squared over 1 squared times 2 squared plus 3 squared over 2 squared times 3 squared. I'm getting pretty sick of writing out all of this. I want to now, and I'm running out of space, so I'm just going to talk you through the next few steps. So just listen carefully. 2 squared and 2 squared cancel out, 1 squared and 1 squared cancel out, 3 squared and 3 squared cancel out. This is not the telescoping part. This is just simplifying it even more, right? And then we're going to have, what's next? 3 squared over 3 squared times 4 squared, I think. And then, yeah, I mean, something like that, right? Oh, sorry, this should be this will be 4 squared and then minus 3 squared over 3 squared times 4 squared. The idea is that this cancels with this. And so now I'm going to switch colors, right? Just because it'll probably be a little helpful for you. We've got 1 over 1 squared minus 1 over 2 squared plus 2 over 2 squared minus 1 over 2 squared plus 1 over 2 squared minus 1 over 3 squared plus 1 over 3 over 1 over 3 squared, and so on. And so the last term, now you can write it out for yourself. I'm not going to do that just for the sake of time. But the very last term that you're going to see is actually going to be it's going to be a minus, and it's going to be, I think, so it'll be plus 15 squared over 14 squared times 15 squared minus 14 squared. So it'll be 14 squared over 14 squared times 15 squared. These cancel out. And so at long last, we're left with 1 minus 1 over 15 squared, which is 1 minus 1 over 225, which is 224 over 225. Now, it looks like we've done a lot of work for this, right? But think about it. We've done so many baby steps, right? Like we went from this and then to multiplying it like that. So very simple steps. It shouldn't take you that long. Especially if you're doing a competition, you've seen one of these questions. When it becomes a habit, you can do it pretty fast. I think I was able to do this one mentally just because I recognize that, well, yeah, I mean, there's a pattern there, and then you just take the first and last term. There's only one thing that I'll note though, right? And just in case you're curious, I will write out the name of the idea we use here as well, telescoping. Right, this is a telescoping idea. This is a very simple example. There can be a lot of trickier examples as well. And oftentimes in trickier examples, what happens is that you've got more than one term at the front and the end being left. So you just have to be super careful. I think it's always a good idea to just write out the first several terms. So that's kind of what we did here, right? We wrote out all of this stuff over here just to make sure that it isn't secretly 2 terms in the front and 2 terms in the back and everything else gets cancelled out. So just be wary of those sorts of things. Those sorts of tricks might come up, but there was nothing like that over here. It was a nice and straightforward answer. And yeah, you've just solved a Harvard MIT math question. Thanks so much for watching. Hope you enjoyed. Not to say it again and again, but please do consider subscribing as well. It'll really help me out. And thanks so much for watching. Bye bye.